In a scratch-off game, if you scratch the 2 dice on the ticket and get doubles, you win $5. For the game to be fair, how much should you pay to play the game? So we're solving for the cost of the ticket, and we want to get the cost of the ticket to work so that the game is fair. If it's fair, then the outcome is $0, meaning that the house does not have the advantage of winning and the person does not have the advantage of winning. So you're not going to get a negative value or a positive value for expectation. It's going to be 0. All right, so what we do with these is we set up a table where we list our outcomes. So this is an expected value table. And for our outcomes, we are either going to win or lose this game. So if we win the game, we win a prize of $5. But we always have to take the value of the prize and we want to know the net profit. So we have to subtract the cost of the ticket. Since I don't know the cost of the ticket, I'm going to let that be X dollars, and I have to subtract X dollars from $5 to figure out the value of winning. Also, I could lose. So if I lose, then I'm just out the cost of the ticket. A loss is negative, and I'm out X dollars. So negative X would be the outcome of losing. Now I want to list the probabilities of winning and losing. So when I'm looking at my ticket, I win if I scratch the 2 dice and get doubles. So how many ways can I get doubles with 2 dice? Well, you can have the first is a 1 and the second is a 1. You could have a 2 and a 2, all the way down to 6 and 6. So there are going to be 6 total ways to get doubles. Now the total events with 2 dice are 36 events. And that's because you have your first dice could be numbers 1 through 6. And then your second dice could be also 1 through 6. So for each of the numbers that you get for the first dice, you have 6 outcomes that you could get for the second, and therefore when you figure that up, you have 36 total outcomes. Now 6 out of 36 simplifies to 1/6. So there's a probability of 1 out of 6 for winning. Now, what's the probability of losing? Well, you could directly calculate the leftover, or you can say that you want the sum of your probabilities to be 6 out of 6 because it has to total up to 1. So if I have 1 out of 6 ways to win, then I'm going to have 5 out of 6 ways to lose. Okay, so the next step is we're supposed to multiply straight across our outcome times our probability. So X is our outcome, and we multiply by the P of X, the probability. So that means I have 5 minus X times 1/6. I'm just going to say 1/6 times 5 minus X is that first product. And then I'm going to have negative X times 5/6. Okay. So if I distribute here with that 1/6, 1/6 times 5 is 5/6, minus 1/6 times X is 1/6X. So that's that first product when it's simplified. The second product, negative X times 5/6, is just negative 5/6X. Okay, so what am I supposed to do with these two to actually find the expected value? Well, expected value is the sum of these numbers, and they're not numbers, they're algebraic expressions, but you still want to find the sum of these expressions. So I have 5/6 minus 1/6X plus negative 5/6X. Now that gives me my expected value equals E. But remember, we want the game to be fair, and we're solving for the cost of the ticket X where the expected value is 0. So we're going to set this equation equal to 0 and solve for X. So let's collect like terms here. So I have 5/6, and then I have negative 1/6 plus negative 5/6. So that equals negative 6/6 or negative 1X. Okay, now if I want to get X alone, I'm going to subtract 5/6 from 0. So I have negative 1X equals negative 5/6. Okay, so finally, to get x alone, you're going to divide both sides by -1. So the cost of the ticket x is equal to positive 5.6, and we need to figure out what that is in dollars and cents. So you just have to divide 5 divided by 6, and you get 0.83. All right, so the cost of the ticket should be 83 cents to make this expected value be fair and be 0.